안녕하십니까?
Good morning, ladies and gentlemen. Welcome to the SMR session of the World Ocean Forum 2023. I am Tae-Ho Lee. I will serve as your MC for today's session. Thank you for joining us at this early hour. Let us begin. This is the first time to have this SMR session. SMR stands for Small Modular Reactor. So this is something that puts together in all different devices. And this is my first time to learn what this means. And this is something which puts together all the key elements of a large-scale reactor and nuclear power plant, such as coolant, as well as the reactor, and all other important features. In this first ever session, I hope that you will get an insight as well as value information regarding SMR. Let me invite the moderator of this session, Dr. Im-In-Cho, the Executive Vice President of Korea Atomic Energy Research Institute. Please welcome him with a big hand. Very nice to meet you all.
This floor, and as well as connecting to event through the online. So as you see here, the subject of this session is the marine SMR as a new energy paradigm. The every elements from the human activities in the world are putting efforts to limit the global warming. Most important task is to achieve net zero emission in 2050. The marine activities are not exception from this movement because the emission from the marine activities are about 3% of the world emission. July this year, IMO announced Green Gas Emission Reduction Strategy 2023 and declared the 2050 net zero emission objective. The realization of this objective needs a lot of endless efforts from all the stakeholders in the marine area, including shipbuilders, shipping company, and regulating bureaus, as well as the research institute. The most important part to reduce the gas emission is to use the carbon-free energy source, replacing the fossil fuel. And in addition, we cannot neglect the importance of the regulation, which will expedite the use of carbon-free energy for the marine area industries. So I think that's why we are here together with the theme of marine SMR as a new energy paradigm. So for this session, I invited experts in developing SMR, as well as the expert in safety area and economic area, and as well as from the area of regulation. So in this session, we'll hear 3 speakers, and after just a short stop, we will invite another 3 panelists, and we will have some discussions. And also, I will invite some questions from the floor as well at the end of the panel session. So I would like to invite first speaker, Dr. Tae-Ho Lee from Korea Atomic Energy Research Institute. He has the Ph.D. degree in nuclear engineering from Seoul National University in 2000. And he is now in charge of the development of various types of SMR for the use of in various industrial areas, including the shipbuilding area. So please, Dr. Lee, to show up here and make a presentation, please, about the SMR development.
감사합니다. 안녕하세요.
Good morning. As introduced, I am Lee Tae-Won, Senior Vice President of the Korea Atomic Energy Research Institute. Around 2020, the IEA published a report. Across the world, about 80 kinds of SMR now being developed, and they are under intense competition. These diverse arrays of SMR sometimes coexist in harmony, but they are also engaged in intense competition. And they're actually in different phases of development. And this indicates that there is a growing international interest in SMR technology. In particular, SMR is very advantageous because it can be used for various purposes. It can also be an effective means to realizing carbon neutrality. So it now draws a lot of attention from around the world. And my presentation today will be about what aspects we have to be aware of in order to apply SMR technologies for marine sectors. In the past, we used the power of wind and ships for long-distance trade. In 1838, the first steamship was invented. So it departed from Bristol in the UK and traveled across the Atlantic Ocean and arrived in New York in 15 days. This steamship was based on coal, and along with the telegraph, the steamship revolutionized long-distance international trade. And after that, after 120 years later, so we had some needs to build and the cargoes in a more dense and manner. And that's how the concept of the container began. So here you can see that this ship transported 58 aluminum containers and finished its journey from Newark, New Jersey to Houston, Texas in 5 days, which opened a new era of containerized shipping. As you know, the introduction of the container in shipping industry has significantly decreased the time for transportation as well as the cost, and therefore again revolutionizing the transportation sector once again. But now we are now facing a very urgent, severe challenge, which is to achieve carbon neutrality. We are facing a new paradigm shift. And in the maritime sector, yes, so we saw several revolutions, starting from the SS Great Western, followed by Ideal X that introduced the concept of container. And now we have to find solutions for green revolution to achieve environment goals. And I believe that nuclear energy could be a foundation to achieving this green revolution. So let me delve into this topic. Global climate change has become a very serious issue, and maritime sector is not an exception. As you know, a lot of carbons are emitted from the maritime sector, and because of the climate change, we now see a lot of natural disasters occurring. For example, like the level of sea increased significantly, seawater temperature also went up, and ocean has been acidified, and this will significantly decrease the amount of catch, and also the Arctic sea ice is now melting. Glaciers are melting. For the maritime sector, in 2018, about 1.76 billion tons of carbon dioxide were emitted. So there have been some serious efforts going on to mitigate the CO2 emission. For example, slow down the speed of propulsion or secondly, using low carbon fuel, and thirdly, optimizing the route to reduce the transition time, or fourth is the using devices that can improve energy efficiency. So these are the efforts to mitigate carbon emission. This is something that I touched upon already. So in 2030, in 2023, IMO announced a new version of greenhouse gas reduction strategy, and it stipulated several goals by phases. The first phase is by 2030, and IMO's goal is to reduce greenhouse gas emission by 20%, and then by 2040 by 70% to achieve net zero by 2050. So in order to achieve carbon neutrality, what kind of energy sources we need? One of the answer or alternative that we can rely on is SMR. I'm sure that SMR will play a pivotal role in helping us achieving maritime carbon neutrality. As you know, nuclear energy is free of carbon emission, and it can also provide a strong propulsion power for ships. So we have large, mid-sized, and small reactors. So here you can see that based on the electrical output, large means over 700, medium between 300 and 700, and small is less than 300. So electrical output is small for SMR, less than 300. But if you look at the components of these SMR, they're actually fabricated and manufactured from the factories and then transported to the site. So on the site, you only need the assembly and installation, which significantly reduces the time for manufacturing. So as for the large nuclear power plant, all the major equipment have to be connected with large pipes. However, the small modular reactor, it enabled the unified design and also the pre-assembly, and it can also effectively eliminate the potential sources of major accidents. It also realized a very compact size. So there are a lot of advantages for SMR compared to large nuclear power plants. What kind of advantages we can enjoy with SMR? I believe SMR is actually being developed in a direction that can respond to various needs of nuclear markets today. First of all, in terms of safety, of course, the large-scale nuclear power plants are safe, but SMR can beef up the safety, and also it can eliminate the potential scenario for nuclear meltdown. And during the accident, we have to have a safety system to maintain the nuclear reactor safe. And usually the large nuclear power plants, they use active safety system because of the large size. However, SMR is small in size, and therefore we just need to rely on passive safety system, which is much more safer than large power plant. And also it can have robust seismic design. And also during the accident, the residents nearby do not have to evacuate. And in terms of economic feasibility, all the major equipment have been modularized, and they are pre-assembled and brought to the site only for installations. So this could shorten the construction period and save money for construction. And also, with the integrated installations, we can minimize the number of human labor input. It can also minimize the risk of the construction delay, because SMRs are small and cheaper than large nuclear power plants. So this could also significantly reduce the initial capex. And because of these advantages, SMR is now on the rise, and a lot of private companies are trying to develop SMRs. And as you know, the SMR can be utilized for various purposes, and it can be utilized for the district heating system, as well as the desalination of the seawater system. It can also be used for the space purpose or the marine sector for various types of energy propulsion. So it has, again, many advantages because it's small. So its advantages are mainly driven by its size. Now, let me switch to a topic of how we can apply SMR to maritime sector to vessels. And there are several requirements to be met for that application. For example, there should be no radioactive release so that the crew can be kept safe. Because crews, they are in the middle of the sea on board, and therefore they have nowhere to evacuate when there is a nuclear accident happening. And also it has to have an excellent inherent safety, and it should reduce the complexity for managing spent fuel. And for the construction and operating cost, again, it should be competitive enough, low enough for competitiveness. And for this, what's necessary is to achieve full modularization of all equipment. And also, in order to minimize the operator's manual mistakes, we have to have the passive safety system. Here you can see the various maritime SMRs that are now being developed. For example, in Russia, they are now constructing 3 SMRs, including Arctica that you can see from the photo. They also have a floating type nuclear power plant using SMR, and they use water as coolant. And or sometimes some companies, they use molten salt as a coolant. So one of the examples is the CMSR developed by Danish company Seaborg, and the MCFR co-developed by a UK company and a US company. So the molten salt reactor is the 4th generation reactor. And the nuclear reactor is small, and therefore we can actually load a lot of cargoes. And also it has a great safety, and the fuel mixture is designed to drain without pumping from the core of the container vessel. And also it eliminates the risk of the hydrogen explosion or many kind of accidents. Currently, our research institute, together with a private company that's interested in developing this technology, we are now initiating the project to develop the MSR. So one project that we are now pursuing is to achieve 100 megawatt hour of the thermal output with the coolant of molten salt and outlet temperature 650 degrees Celsius. And the Korean government has come up with a 6th comprehensive nuclear energy promotion plan that includes the development of the molten salt reactor. And in order to achieve a secure enabling technology for the MSR, together with the Ministry of Science and Technology, we have embarked on several projects. So here you can see that the molten salt reactor SMR, so it's the 4th generation reactor, and therefore technology is still premature. So we may face some challenges for technology development. And also, unlike the ground operation, it has to be applied in the maritime field, and different regulations will be applied, which could again pose us some important challenges. So I believe that it is very important for the government, shipbuilding, and also energy industries to cooperate to realize this vision for carbon neutrality. And with that, I would like to conclude my presentation. Thank you very much.
Thank you, Dr. Lee. Thank you very much for your very comprehensive and detailed presentation talking about what we are doing here for the development of SMR for marine area application in Korea. So please give him a big hand again, please.